Hmm. So, good day everyone. This is a recorded video of your module 3. So, we'll be discussing about the continuity and compressibility. Um, So, ito yung mga topic mo, yung continuity, isentropic flow, compressible flow, energy equation, flow, critical Mach number, and critical pressure coefficient. Actually, yung critical Mach number and critical pressure coefficient yung hindi dapat sa ano pa eh, sa susunod pa. Pero sinama ko na din for overview, no? Magiging topic natin sa Supersonic. So, pinag-aaralan natin to kasi yung mga energy natin, mga molecules, no, nagta-travel na. Kasi doon sa module 1 and module 2, sa current state na tayo ngayon, ang certain point na lang, that na point, no, what is the condition or what is the state of your energy or yung molecules. So, meron tayo ibang variation ng pressure, temperature, and density. So, for now, no, nagmumove na tayo, gumagalaw na yung energy natin or na flow natin. So, yun yung magiging topic natin. If may questions kayo about sa module 1 and module 2, ask ko na ako, and open naman ito din para mas deeply maintindihan kung ano yung natin sa energy natin. And ma-explain ko naman yung once na ano, dumating na tayo sa Supersonic. So, ito yung mga topic and concepts na dapat natin malaman. So, review lang din pa rin ito ng thermodynamics nyo and ng aerodynamics. So, let's start. So, continuity. So, the laws of aerodynamics. Um, Laws of aerodynamics are formulated by applying to a flowing gas several basic principles from physics. So, for example, the physical principle, no, mass can be neither created nor destroyed. So, it's your first law of thermodynamics. So, mass, no, change in mass or change in mass flows equals to density times your area, velocity, and change in time. So, the mass flowing through the stream tube is confined by the streamlines on the boundary. So much as the flow of water through a flexible garden hose is confined by the wall of the hose. So this is a case of what goes in one end must come out on the other end. So the mass flow through the area through through area A is the mass crossing a area per unit time. So no, kung ano daw yung flow mo, kung ano yung meron ka dito, yun yung lalabas sa flow. Pero, no, may condition siya, no, to your area and velocity. Nagbavari yun doon. So, may compressible and incompressible flow din. Na-explain ko natin yun, no? May overview tayo sa module 2 nyo about yun. So, yun yung continuity. Kung yung flow lang ng mass natin. And then, from the equation of the mass above, for area 1, mass flow is equals to your density times the area times the velocity, or which no, it's the mass over change in mass over change in time. So the unit of that is kilogram per second or slugs per second. So English metric lang yan, no? So also the moves flow through area 2 bounded by the same streamlines that flows through the circumference of area 1 is obtained is the same fashion as your mass flow 2 is equals to your density 2, area 2, and velocity 2. So since mass can be neither created nor destroyed, we have from 1 mass flow 1 is equals to your mass flow 2. No? So pwede mo siyang ma-equate. So, kung ano yung nangyayari dito, yun din nangyayari dito sa kabila. So, yung mass flow is the same but varies in density, area, and velocity. Next, no, incompressible flow, sinabi ko din natin na kapag compressible flow, yung density natin, hindi siya equal. No? Kasi nga, no, based on studies, nalagyan niya, sa flow natin, kapag ang mga molecules natin, dumaan mo na dyan sa area na to, nagsisiksikan na sila, which dumadaas yung density mo. No? and your velocity, tumataas yung velocity mo dyan sa compressible flow. So, magkaiba yung state or the speed and density na nangyayari dun sa area natin dito when sa compressible flow. So, compressible flow, 100 meter per second and Mach 3 yung pataas. So, that's the compressible flow. But, no, mas prefer ko na gamitin natin yung zero point 3 pataas. No? Kumbaga, greater than zero point 3 for Mach number. Kasi kapag kinuha mo yung velocity dyan, actually, parang hindi siya aabot or something 99 or 0.29 lang kapag ginamit natin siya sa SSMC. So, prefer na gamitin yung 0.3 pagdating sa compressible. And then sa incompressible naman, no, actually may pagbabago sa incompressible flow, pero hindi siya significant, hindi katulad sa compressible flow, na kung saan meron siyang pagbabago sa bilis, no, ng mga molecules mo. Sa incompressible flow, wala siyang pagbabago, parang hindi siya acceptable or hindi siya significant. So, dito, no, makikita natin sa graph na kung saan yung velocity natin, the velocity density, no, konti na yung changes niya compared dun sa umabot na sa 0.3 above sa Mach number mo, significant na yung changes. Kaya sinabing so dito, no, compressible flow is a myth, so it can never actually occur in nature as previously discussed. However, for those flows in which the actual variation of your density is negligibly small, it is convenient to make the assumption that the density is constant to simplify our analysis. So, yun, no? Continue yung pagbabago sa incompressible compared sa compressible. So, maging aware lang tayo doon. And then, so may problem tayo dito sa problem. Consider a convergent duct with an inlet area of 5 meters squared. The air enters this duct with a velocity of 10 meters per second and leaves the duct with velocity of 30 meters per second. So what is the area of the duct exit? So, actually, napa-recitation ko sa ibang sections. So, yung sa ibang hindi pa nakaka-recitation, may alternative naman tayo doon para malaman or makita yung maka-earn kayo ng recitation kasi sa iba, ito yung recitation during synchronous classes. So, sa yung alternative naman, so ngayon, kung gusto nyo mag-practice in solving, so just pause the video and play it again, no? Kung para mahasa kayo, no? Or ma-master nyo yung mga formulas. So, then yung solutions, no, makita yun naman din where incompressible siya, gagamitin mo lang yung formula na area 1, velocity 1 is equal to area 2, velocity 2, since your density is equal to the end, no, to the 0.1 to 0.2. So, makukuha natin yung area. Next, same pa rin, no, kung gusto mo practice, just pause the video, then play mo lang siya after mo mag-solve. So, dito, no, consider a divergent duct with inlet area with an inlet area of 3 meters squared and an exit area of 6 meters squared. So, air enters this duct with a velocity of 95 meters per second. What is the velocity, no, at the exit? So, titingnan natin kung anong velocity niya. Since nandito naman, hindi pa rin siya compressible kasi 95 meters per second siya. So, divergent, kapag di ba divergent, maliit to palaki. Kapag convergent naman, maliit, palaki to maliit. So, sa concept nyo, malalaman nyo din yan. So, sabi dito, from divergent duct siya. Divergent duct, which is, ito, nasa taas, divergent. So, sa concept lang nito, makikita natin, no, kung tataas o lalaki yung velocity natin. So, sabi dito, ito yung exit, is the velocity in exit. Dito naman, yung inlet mo. Inlet. So, this is your exit inlet. So, di ba kapag galing ka sa maliit na area, papuntang palaki, Unang palaki. From dito, mabilis yung speed mo. Pero pagdating dito sa labas, lumagal na kasi nga lumaki yung effect. Is naging maluwag siya paglabas ng hangin. So dito, so masisimplify mo dyan na kung saan pag sinod mo siya, yung velocity mo is lumagal pagdating dito sa exit, sa divergent na. Okay? So, ma-justify mo na tama yung sagot mo since lumaki, or I mean, limit yung speed mo. Kasi nga, lumaki yung area, which is given naman dito. So, sa area 1 natin is 3 meters squared and the area 2 is 6 meters squared. So, lumagal yung speed. So, tama yung sagot natin. So, kumbaga yung concept, no? Kumbaga magtaka kayo kung tumaas yan. So, ibig sabihin mali yung ginamit mo yung solution. Okay? So, ito naman sa baba is convergent. Convergent. Okay? Next. Consider air flowing in a divergent duct. Divergent duct with an inlet Mach number of 0.2 with an area of 7 feet squared and temperature of 529. And if area of the exit 16 feet squared, no? So malaking area doon. What is the velocity of the air at the point? So sabi dito yung hinahanap natin, what is the velocity of dito sa exit natin. Okay? So sabi consider air flowing in a divergent with an area of temperature. If area of the exit is, so dito nga sa exit yung hinahanap sa divergent duct. So, same pa rin, no? Ano pa rin siya? Ah, dito. Yung compressible flow, no? Makuha natin na ang speed natin doon sa given tayo ng temperature, Mach number natin, given tayo, makuha natin speed, which is 223. So, pagdating dito, sa volume, sa velocity 2, we have 97.7. So, same pa rin. So, gamitin mo lang yung compressible continuity, no? So, justify din na kung saan yung speed natin lumagal pagdating sa exit kasi nga divergent siya. So, yun ang analyzation and conceptual, yung concept ng idea. Okay? So, next, consider a convergent duct. So, convergent naman daw. No? Convergent. So, yung convergent natin with an inlet area of 8 meters per 8 meters squared. The air enters this duct with a velocity and density of 120, no, meters per second. So the air then leaves the duct with velocity of 180. So bumilis siya. The ratio of our pressure temperature in the end of the duct is 1020. What is the area of the duct exit? So kung titingnan mo yung problem, no, meron na tayong area which is malaki dito, no? And then we have the density and speed, yung velocity and density dito, no? Sa ating inlet. Then yung velocity natin mataas kasi nga lumit yung area natin. No? So sa question pa lang mo, dapat yung area mo is mas maliit doon sa maliit sa 8 meters squared natin. So yun yung magiging assume mo na dapat maliit yung area yung sa exit. So, just to, ano lang, pause the video kapag gusto mo so then play the video if tapos na. So, tingnan natin kung bababa nga sa idea natin. Bababa dapat yung area sa exit kasi nga mataas yung velocity mo, no? And yung ano natin, yung density natin, titingnan din natin kung tumaas. No? So, dito sa problem, isa siyang compressible flow. Makikita natin na kukunin natin yung density, no, from your pressure temperature ratio, which is in the exit. So, nakuha natin density na 3.5530 kg per meter cube. So, mag-justify na siya, no, na mas malaki siya kaysa dun sa density natin sa inlet. So, di ba dun pa lang parang may sabihin, ay, tama na yung sagot natin. And then, no, ano natin siya, i-equate natin sa M1 or your mass flow 1 and mass flow 2, no, makuha natin, no, yung area 2, which is 3.0021 meters squared, which is nag-justify din ng tumaas kasi ang velocity natin. So, tama ito yung magiging sagot. So, yung concept ng continuity flow. So, just to ano lang, kumbaga, kung yan, mataas yan, ibig sabihin mali yung sagot mo sa 8 meters squared. So, yun ang concept ng continuity. Okay? And then, we have first law of thermodynamics. Kanina, sabi natin na energy can neither be created or destroyed, only altered in form. So, ano ba ibig sabihin nun? O, kung sinasabi niyang hindi daw na ginagawa, na-altered lang siya ng form. So, hindi natin siya nasisira. Kasi no, sa energy, no, we can change heat energy, for example, heat energy to mechanical energy into electrical energy. So, saan na-apply yun? Di ba na-apply yun sa ano natin, sa mga coal industry, sa kuryente. Kasi di ba, kunyari, may uling ka, ah, gagawa ka ng combustion dyan, iinit yan, tapos mag-aapoy yan. May example na ako. May example na ako. Aapoy yan. Apoy. Yun. Tapos, di ba, yung heat na ilalabas niyan, or yung steam na ilalabas niyan, under, kunyari, may boiled water ka dito, or boiler, or may tubig ka dyan sa loob dyan, kung ano mo yung use ng nilagay. So, may tubig ka dyan, kukulo yan, dahil dun sa energy, heat energy. So, nag-transfer ng heat energy. And then, may lalabas na steam, lalabas yung steam dyan. And then, meron tayong turbines dito. May turbines tayo dyan. Turbines. So, from heat energy to mechanical energy. Kasi, kapag dumaan yung steam mo dyan sa turbine natin, aandar yan, iikot. So, mechanical work na yun, no? Mechanical energy. Pagkatapos, no, sa mechanical energy natin, under niyan, meron tayong generator. Kunyari, example generator, which is, may, ano yan, electrical. So, papagandahin niya yan hanggang maglabas siya ng electrical energy. So, that's the concept of your first law of thermodynamics. First law of your thermodynamics. So, heat added and work done on the system cause a change in energy. So, babago yung energy mo, depends din sa gagawin mo, sa work na gagawin mo. So we have here no change in our heat plus your change in work is equals to your energy. And then no, for a given change in energy, there are infinite number of ways by which heat can be added and work done on the system. So pag work done negatively. Kumbaga, pag work done, negative siya. Pero kapag work done on the system from surroundings, parang from surroundings, from your surroundings to your system, negative yun. Pero kapag yung system ang gumawa ng work sa surrounding natin, it's positive. So, but we are primarily concerned with three types of processes. We have adiabatic, reversible, and isentropic. So, sa reversible process natin, we have change in our heat minus to our pressure change in volume is equal to your change in energy. So, from your thermodynamics, so na-explain naman yan dyan. So, ano na lang tayo dito, application ng mga energies natin. So, ito, recap lang din ng thermodynamics niya. So, ano nga ba yung tatlong yun? Adiabatic, reversible, and isentropic sa first law of thermodynamics natin. An adiabatic process in one in which no heat is added or taken away. So, a reversible process is one in which no frictional or other dissipative effects occurs. And an isentropic process is one which is both adiabatic and reversible. So sa adiabatic process, wala tayong heat na dinadagdag or nababawasan. Yung heat na, kumbaga yung heat natin, sige sa flow, depende lang sa flow mo. Basta tuloy-tuloy siya. Tapos wala siyang nawawalang energy sa kanya. Yun yung adiabatic. And then, sa reversible naman, wala tayong iniisip na no friction or other dissipative effects occur. So, nagagamit natin yan. Kumbaga, meron kang tube dyan, meron kang flow, meron kang flow dyan, no? kumbaga walang naglo-loss na energy dito sa stream tube natin or our walls no, or yung mga boundaries natin. Hindi yan kasama yung reversible process. And then, isentropic is, ano lang, combination of our adiabatic and reversible. Okay? So, entropy in the second law of thermodynamics. So, entropy is the disorderness or randomness ng energy natin. So, energy in a system that is no longer available for doing mechanical work. So, tell us in what direction a process will take place. So, entropy of the system plus its surrounding increases. Entropy of the system plus its surrounding stays the same. So, sa picture natin, makikita natin no, kung saan yung entropy, no, kumbaga, sample, meron kang ice cream. And then, natunaw yung ice cream mo. No? Ano, kumbaga, gaano siya, yung percentage niya, no? Or your probability na magiging ganun, no? Magiging the same yung order, yung, ano niya, yung pagtunaw niya. Kunyari, ice cream ka, natunaw ka, ganito yung shape niya. Kumbaga, yan yung ice cream mo, yung natunaw. Pero nung natunaw ulit siya, nung isa ka ulit na yung tunaw, magkaiba naman siya. Kumbaga, mas malaki yung area na. Yun. So, may mga, ano ka dyan, energy or molecule. So, higher, mas mataas na entropy kapag mas malaking area. Hmm? I mean, dito, no? Mas mababa ang entropy mo compared dito. Mas mataas yung entropy mo dito kasi mas malaki yung area ang tinatravel ng mga energy mo. Parang ganun yung concept ng uh, second law of thermodynamics natin, which is entropy. Kasi dito, no, kumbaga sa hindi na siya magiging ordered, no, kapag natunaw siya, hindi niya na ma-reach yung dati niyang position or uh, dati niyang form, which is nabuo pa siyang ice cream. Kumbaga ganito yung sample ng entropy natin. Okay? So, parang ano yan eh, parang combination na kung saan mas maraming combination, mas pataas yung entropy. Ang ganun yung concept ng entropy. So, entropy, no, na discuss ko naman yan sa thermodynamics yun. So, ni-recap lang natin kung ano talaga yung entropy. So, di ba sinabi natin dito na entropy of the system plus its surrounding increases. So, sa universe natin, di ba, so mas malapad yung entropy natin, travel yung energy natin, sige pa rin sa flow niya. And then, entropy of the system plus its surrounding stays the same. Pero pare-pareho, yung mga molecules na dyan, no? Yung kumbaga nagkawatak-watak ng sila. Parang ganun yung concept ng entropy natin. So, change in entropy is greater or equal to your uh, change in heat, your change in time. So, entropy of the system and your T is your temperature. Okay? Then, no, if the process is adiabatic, your change in entropy, no, is greater or equal to zero. So, hindi siya kailangan bumaba ng zero. Negative yan, hindi na. Kapag negative yung entropy. So, dapat ang entropy mo, change in entropy mo is mataas. So, entropy change for a calorically perfect gas between two states. We have, saan tong dalawang formula ko? Diba ito is to your specific heat at constant volume and specific heat at constant pressure. So, galing lang yan sa change in entropy is equals to your change in heat for time and from your enthalpy and internal energy. So, ito na yung galing yung entropy natin. So, remember that formula. So, we have an example here. The pressure and temperature ratios across a given portion of shock wave in air are pressure 2 over pressure 1 is equals to 4.5 and your temperature ratio then T2 over T1 or temperature 2 over temperature 1 is equals to 1.687. So, where 1 and 2 denote condition ahead and behind the shock wave. So, calculate the change in entropy. So, ang ano natin, ang units ng entropy natin is same sa ating Cp and Cv, which is your specific heat at constant pressure and specific heat at constant volume. So, foot-pound per slab, runtime, and joules per kilogram Kelvin. So, nyo yan. Madali lang naman, di ba? Ang change in entropy natin, change in entropy, is equal to your Cp ln T2 T1 minus your ln natural log of your T2 over T1, where sa natin change in entropy sa constant specific heat at constant volume, we have CV ln D2 as I kanina pagpamuli natin D2 plus yung positive yan kasi sa derivation malalaman yung ln T2 over T1. So if you remember our formula kasi nalabas sa question. So, yan. So, sa derivation yan, guys. Ay, so, baliktad pala to. So, dapat P2 to. P2 to your P1. So, P2. So, mali itong translate ko. Mali yung remember. So, ito yung formula. So, ulit natin. Baka sabihin nyo, mali yung sinulit ko dito sa discussion. So, changing. Yan. So, yun. CV. And then, P2 over P1. CV plus R ln P2 over V1. So, guys, yung sinabi ko sa inyo na, kumbaga, sa derivation niya, kaya naging positive yan. Kaya sabihin, bakit naging ano yan? So, may derivation yan, integration ng entropy natin and our internal and enthalpy ng energy. So, sa CP naman, no, we have CP is equals to ln P2 over T1. And is our universal gas constant ln. Actually, mamimipang yung T1. So, yan. Yung mga gawin formula natin. Okay. So, solve tayo. Kanina, nabasa na natin yung natin. So, sabi dito, given ka na ng pressure ratio. So, ito yung pressure ratio natin, which is this one, pressure and temperature. Na? So, given nila. So, CP na lang hanapin mo. And then, pwede mo na makita ang change in entropy natin. So, try to solve, guys. Post the video. And, kung tapos ka na, play mo na. Okay. So, makikita natin yung input lang naman yan. We have CP na kung saan 6,006 and our CP sa English metric, which is 1,004.7. So, input mo siya dyan sa formula natin. Then, makuha natin yung dalawang change in entropy natin. So, dyan, change in entropy hanap. So, kung kunyari, sinanap ka ng what is your entropy 1 or your entropy 2. So, dun ka mag-formulate sa formula natin. So, just try to remember. And the concept na sinabi ko kanina, kung ano ang entropy. Okay? It's entropic relation. So, both adiabatic and reversible. So, kanina, discuss natin yun. Which your heat is 0 and your change in entropy is 0. So, ito yung from last equation natin sa entropy change for color to gas between two states. So, galing siya dun sa entropy natin kung saan nakuha natin is entropic relations natin. So, actually, dito. So, local flow velocity ratio over V1 over V2 sa local speed of sound. So, doon natin siya nakuha. Okay? Derivation ng din. So, ito yung gagamitin natin. K yan, guys, yung sa taas or your specific heat ratio. Okay? And then, an isentropic process is one in which there is neither heat exchange nor any effect due to friction. So the source of the word isentropic is defined thermodynamic variable called entropy. So ito pa yung isang formula. Itong sa taas kasi is galing kay Anderson yan. So pwede mo siyang ma-derive sa ganito, under sa module C. So the equation above relates the temperature and velocity. So velocity yan of two different points along the streamline again. If all the streamlines emanate from a uniform flow far upstream, then this equation holds for any 2 points in the flow. So ano yun may point 1 gamit point 5. So not necessarily on the same stream. Moreover, it is just powerful and necessary for analysis of compressible flow as the isentropic relationship. So, magagamit natin siya sa compressible flow and isentropic relationship. Pag sinabi, flow is isentropic din from point 1 to point 2. So, magagamit mo yun together with your entropy. And then, yung compressibility, ito, okay, so compressibility. So, sinabi natin yung non-compressible, your Mach number is less than 0.3, where compressible is greater than 0.3. So, speed of sound na na-discuss natin nakaraan. Okay, yun lang yun. Where your velocity is the local flow velocity of or your object over the local speed of sound. Okay, so governing equation for invisible, compressible, and compressible flow. So governing equation for invisible and compressible flow, we have Bernoulli's and continuity. No? So variables natin dyan is your pressure and velocity, which is this is one is your pressure dynamic and static pressure. And then, inequate lang natin siya for our compressible flow, which is your continuity and your energy. So, from Bernoulli's, na-equate natin yan using our continuity flow with our enthalpy and internal energy. So, nakuha natin yan, may derivation din yan. So, sabi ko nga, na application na tayo, there's no need na mag-equate or I mean mag-derive kasi nga na-discuss niyan sa thermodynamics and aerodynamics. Okay, so energy equation can be defined as your enthalpy plus your velocity 1 squared over 2 equals to your enthalpy 2 plus velocity 2 squared over 2. So we can equate yung enthalpy natin sa specific heat at constant pressure natin. Okay, so yun yung magiging formula natin. So, stagnation pressure, so pressure exceeding at a point or points the flow where velocity is zero. So, masasabi natin, kunyari sinabi na at total stagnation pressure or the total pressure point. So, mahanap natin what is your, sabi natin, velocity. Since given ka na ng total enthalpy, sabi mo, total enthalpy ka. So, may flow ka dito, number b squared over 2. Yung concept ng ano natin, enthalpy. Magagamit natin dito. So, nire-given yung enthalpy. Total enthalpy, which is the velocity. So, diba? Madali na siyang i-solve. So, adiabatic flow, where your temperature, total temperature, or 1 sa 2 is equal, and your enthalpy from 1 to 2 is equal din. And then sa isentropic flow, your density and pressure is equal to your density and pressure sa point 2. So, yun yung ano natin yung isentropic flow since na yung velocity natin at that point is 0. Pag sinabi lang na total pressure or in your stagnation point. So, an aircraft is flying where the pressure and density are 150,000 pascals and 1.5 kilogram per meter cube. So the aircraft is traveling at a flow velocity of 300 meters per second. And the point on the wing, the velocity increased, no? So pag reach siya dun sa airfoil natin, nag-increase yung speed niya from dito sa point dito. So, kulang sulit. From point dito, point here, sa airfoil, kung saan yun. Tumaas yung speed natin. What is the temperature at the point of the wing? So, nahanap natin yung temperature. Given tayo ng CP and our R, which is your universal gas constant. So, try to solve lang. Post the video then. Like, na-solve din. So, using our formula, no? Kasi nga, compressible din. Yung gagamitin natin. Kasi mamaya, magito dito. Kung ano gagamitin dyan. So, ano lang natin? Temperature, yung CP, which is equal naman yun, same yung CP mo. And then, equate mo lang siya sa equation natin, yung unity equation ng enthalpy. We'll get temperature 2. Okay? So, pause mo yung video, tingin mo kung mali ka o tama. From your equation ng state, kunin mo yung temperature mo. Then input mo lang dun sa pangalawa, which is sa point 2. Travel na yun, yung condition ng point 2 mo. So, yun yun. Okay? Next is consider aircraft flying with a velocity of 450 feet per second at altitude where all the conditions are at standard sea level. So at the point on the wing, the velocity is 550 feet per second. So calculate the temperature at this point. So assume na yung constant heat ratio natin na at heat specific heat at constant pressure is 6,006. So medyo nagugulo-gulo na. And then, no, input lang din, malalaman natin yung temperature 2 natin, which is given lang tayo ng temperature 1. So, makuha natin yung temperature 2 is 510.6750 Kelvin. Okay? Next is critical Mach number and critical pressure coefficient. So, ito, overview lang. So, malapit na tayo mag-supersonic. So, alam ko rin na meron din ganito sa aerodynamics, which is pakyaw lang din. So, dito, lalagyan ko na yung overview kasi pag-uusapan natin yung Mach number sa susunod. Okay? Ng modules. So, consider the flow of the airfoil. We know what that is. As the gas expands around the top surface near the leading edge, the velocity and hence the Mach number will increase rapidly. So, tumataas yung speed natin. Katulad dito sa example natin kanina. No? Kung saan, kunyari, may string tubes ka dyan, may airfoil ka dito, may string tube ka. Example lang, kasi di ba magkakaiba yung so, string tube from dito. Pagdating dito, kasi syempre, lilit yung area mo dito. Lilit yung area mo dito. Tataas yung speed mo, and your Mach number will also increase. So, it's justify mo ng Bernoulli's theorem natin, ng law of continuity. So, kumbaga, yun yung mga naging concept natin to reach this point. No? Okay, so by definition, no, the free stream Mach number at which sonic flow is first obtained somewhere on the airfoil surface is called the critical Mach number of the airfoil. So, yung magre-reach ng speed of sonic, or your Mach sonic speed. So, dyan mag-create ng shock wave. So, overview lang naman. So, we have the formula here. So, ito yung sinabi ko kanina din na critical Mach number for the airfoil is 0.61. Example lang. We'll see later that our critical Mach number is an important quantity because at some free stream Mach number above our critical Mach number, the airfoil will experience a dramatic increase in drag. So, nagiging ano rin yun, kumbaga, condition para maano natin ang maintindihan natin kung saan nag-create ng drag. So, we have a different drag, you know? So, wave drag, since sa shock wave natin, nakaroon na rin ng drag doon. Okay? And then, no, critical Mach number, so this is the example ng kung saan nagkakaroon ng shock wave from yung surface. Depende sa area ng magiging airfoil. Okay? So, may supersonic flow dito. We have naman shock wave dito. Magkaroon ng shock wave. So, pagtawid niya, subsonic siya. So, may explanation dun kung bakit ang nangyayari. Okay? So, sa susunod ng mga topics, may explain yun kung bakit siya nagiging subsonic. Okay? So, supersonic flow, dalawa siya ng mga shock wave, what will happen to your speed. Okay? And then, we have here the critical coefficient of pressure or CP, no? Kung saan related siya sa free stream Mach number natin. So this is the formula. Actually, itong formula nito galing siya sa isentropic relationship to your Mach number. So overview lang nilagay ko na dito. And sa module nyo kasi nakalagay lang din doon. So, let's try sa susunod ng mga module paano na-derive kung paano saan siya nanggaling. Actually, dun siya nanggaling na sinabi ko sa isentropic relationship with your Mach number. Kasi itong 1 plus 1 of k minus 1 your Mach stream and k to k raised to k over k minus 1 sa isentropic value. So, nirelate lang siya dyan. No? So, we have two formulas here. Ito, sa free stream Mach number natin, which is yung M mo, hindi pa umabot ng solid. Pag yung M mo, or your Mach number sa baba dito sa formula, pag naging 1 yan, yung critical, no? Magiging critical coefficient of pressure natin. Putting dito. So, let us pick the particular point of the surface where your Mach number is equals to 1 or sonic. So then by definition, your CP or your coefficient of pressure is equal to critical coefficient of pressure, putting your Mach 1 into the preceding uh, coefficient of pressure or equation we obtained. So lalagyan mo siya, input mo siya dito, which is yung Mach number kasi is 1 yun, di ba? So that will be your kumbaga formula, typically, coefficient of pressure. So, CP. Saan ba nakagamit ang CP? Kapag yung, nasaan kung saan yung Mach number mo, di ba? Nandun yung critical coefficient of pressure mo. Okay? So, mag-i-identify nyo kung saan. Kasi nga, yung pressure mo, di ba? Parang medyo sa ano natin, sa aerodynamics natin, medyo ano siya, yung point siya kung saan nandun yung center or your concentration ng flow natin. Okay? So, yun yung CP. And related to your phase 3 Mach number. So, for the equation of your critical Mach number, we can use the Brown-Prandtl-Glauert equation as it gives the variation of your CP or your coefficient of pressure given point on the airfoil surface as a function of your phase 3 Mach number. So, ginagamit natin itong formula na to, yung Prandtl-Glauert, sa correction of compressibility on pressure coefficient. So, the low speed pressure coefficient. No? This formula is reasonably accurate only for 0.3, no? Above, no, or greater than 0.3, less than 0.3, I mean, within your 0.3 to 0.7. So, yung phase 3 Mach number, mas mababa siya 0.7, pero mas mataas siya compared dito sa 0. Okay? So, doon na siya nagamit, doon siya naging accurate. So, pag tumaas na like 0.8, so iba na yun, ibang formula yung gagamitin natin. So, ito lang yung formula natin, which is your CP, who is the low speed pressure coefficient. Okay, so when the flow becomes sonic at the point of minimum pressure, the pressure coefficient given by the prior equation ng kanina is precisely the value given by the critical pressure coefficient. So, i-input mo lang to, which is your CP naman is equals to your CP O over your square root of 1 minus this 3 Mach number squared. So, ito yung formula natin. Okay? So, pag-ibig na lang natin kanina. So, lalaruin mo lang mga formulas. So, try to write those formulas from your aerodynamics then concept and then overview. Okay? And then, no, the value of our critical free-stream Mach number that satisfies the equation showing the value when the flow becomes solid at the point of maximum velocity, no, that is the value of your free-stream of Mach number obtained from the equation in the critical Mach number for the airfoil. To emphasize this, we write, no, it with free-stream Mach number replaced by MCR or critical Mach number. No? Kasi yung sonic ni, kumbaga yun yung critical Mach number at that point. So, critical Mach number, the free-stream Mach number at which your coefficient of drag sa seeding begins to increase rapidly is defined as the drag divergence Mach number. So, dapat yung drag divergence Mach number natin is hindi less than siya sa 1, and our critical Mach number is less than siya sa drag divergence Mach number natin. No? So, dito, no, sinabi natin din na dito din yung formula, ginagamit yung formula natin kung saan na mas babawa siya sa yung 0.3. I mean, yung what we call this one, na kung saan, yung range ng free-stream Mach number natin, 0.3 to 0.7. So, dito naman, na dapat yung critical Mach number natin, yung drag divergence Mach number natin is mas mababa sa 0.1. Then, yung critical Mach number natin is mababa sa Mach drag divergence natin. So, yun yung concept ng natin, critical Mach number and the critical coefficient of pressure. So, we have a sample problem here. What is the critical value of pressure coefficient for your CPR for an airplane flying at 500 knots in air at 25 degree Fahrenheit. So, kung gusto nyo sagutan, pause nyo ng video then play nyo lang. So, remember the formula na gamitin natin. And then, no, sa knots natin, no, equals to 843.33. Yung ginagamit natin na conversion, no, sa knots is 1.852 kilometers per hour kasi mas accurate siya no, kaysa dun sa meters na sabihin nito. And then, kasi may ano pa yan, actually point something kapag meters. No? So, dito, nilagyan natin ng kilometers kasi after ng kilometers, di ba, mag 100, 1,000, 1 kilometer is to 1,000 meter ka. And then, hours naman. Diba, mas accurate to. Itong 1.852 compared dun sa meters na mga makikita tayo sa internet. So, ito yung mas gagamitin. And then, sa, ano natin, sa feet per second, or in our English, ito yung gagamitin, which is 168,781. 1.68781 feet per second, na conversion ng 1 knots natin. 1 knot. Okay? So, input mo yan, no, through our formula, from your speed of sound, makukuha natin yung speed of sound natin. Kasi given ka ng temperature, no? Yung sinasabi ko, yung speed of sound is nakadepende. Hindi lang lagi sa SSLC. And then, we'll get our Mach number, which is 0.7. No? So, magagamit natin yung formula kanina. Sinabi natin na critical pressure, critical coefficient to pressure. And then, input natin siya, given tayo ng Mach number or our freestyle Mach number, which is 0.7812. And then, input mo lang siya, remember your formula, and then, makuha natin yung critical pressure coefficient natin. So, it's negative 0.488. Okay? So, pagtapos yun, meron kayong mga activities modules, which is 10 problems, which is magpapasa din with 1 week and 5 days. So, kung may tanong kayo or questions about the lesson, ask nyo lang ako. And siguro may mga nasabi ako mali dito, sabihin nyo lang din sa akin. Kasi minsan na nilimutan ko yung sinasabi. Kasi hindi ko din pinapanood yung video. I'll just discuss it. So, pinakorek ko naman kung mali ako ng salita. May pinagugulgulan lang. So, yeah. Okay. So, it's the module 3 continuity and capacity. So, question kayo, ask na kayo, and then sa module C, gawin nyo lang din. Okay? So, basta comply lang guys. Okay? So, start ko na to. So, thank you for watching and thank you for listening. I hope na may nasusunod din sa video. So, susunod module 4 na, which is the last module for your prelims. So, kaya yan. Bye-bye. Good luck.